Hi, everyone. Welcome to our presentation on a novel uterine suture technique for the treatment of postpartum hemorrhage. Postpartum hemorrhage is a serious condition defined by excessive blood loss following childbirth. Uterine atony, the leading cause of postpartum hemorrhage, leads to the uterine muscles being unable to properly contract, thus leading to excessive bleeding. This condition affects over 14 million women each year and is the leading cause of maternal death globally.
Existing treatments involve applying compression sutures to the uterus to stop bleeding, but are prone to comorbidities. The B-Lynch technique is currently the most widely used, so our compression technique is compared to it in testing. Our pre-tied uterine compression system will reduce operation time, minimize training, and limit complications. A silk fibroin graft hugs the top of the fundus and is secured to the bottom of the uterus using surgeon knots and slip knots. The pulling ends of the slip knots apply even compression supported by the graft and horizontal strands. In testing, we found that the grafts would degrade in the body by day 14, meaning compression would be sufficiently applied. Benchtop validation testing was done to compare the blood loss and forces between our prototype and the B-Lynch technique.
Last year's work comprised of validating the use of our novel compression technique versus the B-Lynch technique and a control, which was manual compression. Our compression technique exerted around the same amount of forces as the B-Lynch technique, but took significantly less time to apply the device. This year, we focused on getting more accurate readings when it came to the forces applied compared to last year. Our second and current iteration is made up the same Belostat sandwich, but cut so that it can easily conform over the uterus and is placed in strategic spots where we expect the forces to be concentrated during the use of our device and the B-Lynch technique. And here's a brief video showing the new pressure sensors and how sensitive they are. As you can see, that they're very sensitive when you place a force on them.
Future work for our project includes conducting more tests and creating reiterations of our prototype to ensure consistency in the placement of the knots. We will also be using our new pressure sensor grid in ex vivo studies at the medical center to validate our prototype even further. As these tests progress, further adjustments need to be made to our packaging model to ensure the highest efficiency, which Wendy will touch on later. Once all of these tests are complete, we will send the full prototype to the medical center to conduct feasibility tests with physicians. We have conducted a qualitative ex vivo study where we have confirmed that our prototype would work on an animal model. However, we would like to integrate our pressure sensor grid onto the uterus before applying the device to validate our prototype quantitatively as well, in comparison to the B-Lynch and a control. These tests will be conducted in the near future.
The current packaging model is designed to prevent the suture from getting tangled. The two pre-tied slip knot are held in place by the compartments on the left, and the 4 compartments on the right hold the vertical strand with the pre-tied surgeon knots. The design is still subjected to adjustment as we move on with testing.